This is our Formal Lab Project 2 for LB273, investigating viscosity and drag forces in liquids. Our motivation and context behind this experiment revolved around the research question of how does the terminal velocity on an object vary for different liquids, with a goal in mind of determining how the viscosity force and drag force on a constant object vary when dropped within different liquids. A brief outcome of this experiment was vegetable oil had a terminal velocity value of 0.5 meters per second. Corn syrup had a terminal velocity value of 1.9 times 10 to the negative 2 meters per second. And water had a terminal velocity value of 0.75 meters per second. And our why in this experiment is determining the terminal velocity of a constant object reaches for various liquids helps us to better understand the drag and viscosity forces and their effects for those liquids.
So our method for this experiment was to take a metallic sphere and drop it into a graduated cylinder filled with a liquid, either corn syrup, vegetable oil, and water, and record these drops for further tracker use. These videos were then analyzed in Tracker in order to determine the velocity, position, and acceleration of the sphere. These were used to also determine the terminal velocity of the sphere in that liquid and the forces of resistance based on that terminal velocity.
For our experimental design, the independent variables were the types of liquids used, which were corn syrup, vegetable oil, and water. The response variable was the terminal velocity, and the control variables were the metallic ball and the graduated cylinder.
Shown here are two force diagrams of the metallic ball being subjected to the various forces, one of those being a downward force of gravity due to Earth on the ball, and the top forces being the resistance forces. The important thing to notice is that the force diagram at terminal velocity shows the sum of the resistant forces being equal in magnitude to the gravitational force, but opposite in direction, indicating a net force of 0.
Shown to the farthest right is the system scheme. We're more focused on the force resistance between the liquid and the ball and the force of gravity between the ball and the Earth. Shown in the middle right is the motion map. You can see the ball starts at rest, and then as it falls, it increases in velocity until it hits terminal velocity, and then it hits the bottom and stops. The energy pie charts show a similar thing to the motion map, where at the beginning it has all potential energy, meaning it's at rest, and then as it falls, it gains kinetic energy and internal energy, or energy of resistance. For water, it had a terminal velocity of 0.75 meters a second, and it hit this terminal velocity in 0.15 seconds. And then it was determined that the drag force for the ball in real life had a drag force of 0.018 newtons and a viscous force of 9.2 times 10 to the negative 4th newtons and a Reynolds number of 20, which indicates that the drag force was more prevalent than the viscous force.
For the results for vegetable oil, the computational model calculated terminal velocity to be 0.52 meters per second, while Tracker calculated it to be 0.50 meters per second. For time until it hits terminal velocity, the computational model calculated it to be 0.060 seconds, while Tracker calculated it to be 0.13 seconds. Then Tracker calculated the drag force to be 0.0068 newtons, the viscous force to be 0.050 newtons, and the Reynolds number to be 0.136, which indicates that viscosity had more of an effect.
Shown here are the results for corn syrup for both our computational model and the tracker. The terminal velocity for the tracker for corn syrup would be 1.9 times 10 to the negative 2 meters per second, with it taking 0.58 seconds to reach that terminal velocity. The drag force calculated by tracker would be that of 9.2 times 10 to the negative 4 newtons, and with a viscous force being 0.032 newtons, and a Reynolds number of 0.029, indicating that the viscous force would be the more prominent force. Shown here are results of the calculated values of tracker shown on the previous slides.
In conclusion, it was determined that corn syrup had the lowest terminal velocity due to the resistive forces canceling out the force of gravity the fastest, proportional to velocity. It was also determined that water had the highest terminal velocity due to the resistive forces canceling out the force of gravity the slowest, proportional velocity. Or as the density and viscosity coefficients change, the terminal velocity of the object changes as they are proportional to those values. And increasing the viscosity coefficient and density causes terminal velocity to decrease as the resistive forces of F, viscous plus drag, increase more rapidly with an increasing velocity.
The take-home is that changing the fluid of travel changes the resistive forces that interact with an object. Thank you so much for listening to our lab report.